Hello everyone, and welcome to this virtual technical talk. Want to be a hero? Know how to justify an optimization project and make it happen. My name is Jessica Tremblay-Labelle, and I'm the president of the ISA Montreal section. Before continuing with the ISA presentation, I will start with a safety share. With the COVID situation, I'm currently working in my stepdaughter's bedroom. This morning, I slept on one of the sheets she had left lying on the floor. So, even if we are working from home, we must make sure to keep our workspace organized and clutter-free. Which brings us to the short ISA presentation. The International Society of Automation is a nonprofit professional association for engineers, technicians, and management engaged in industrial automation. It provides standard-based technical resources for people who apply engineering and technology to improve modern automation and control system used across industry and critical infrastructures. Founded in 1945, ISA develops widely used global standards, certified industry professionals, provides education and training, publishes books and technical articles, host conferences and exhibits, and provide networking and career development programs for its 40,000 members and 400,000 customers around the world. We serve process manufacturing industries like chemicals, food and beverage, and oil and gas, discrete manufacturing industries and utilities like power and water wastewater. We develop cutting-edge resources on topics like asset management, enterprise integration, control systems, cybersecurity, instrumentation, plant maintenance, and safety. ISA certification provides an objective third-party assessment and confirmation of a person's skills. ISA currently offers 2 certifications programs, Certified Automation Professional and Certified Control System Technicians. ISA offers 3 levels of the CCST certification, requiring differing degrees of technical experience, education, and training. ISA also offers 2 certificate programs, the ISA IEC 61511 Safety Instrumented Systems Certificate Program and the ISA IEC 62443 Cybersecurity Certificate Program. The ISA brand family exists to serve the automation professionals and their company and includes Automation.com, the Automation Federation, the ISA Security Compliance Institute, the ISA Wireless Compliance Institute, and finally, the ISA Global Cybersecurity Alliance. Now, let me introduce you to the presenter of today's technical talk. Michel Ruel is a senior process control engineer who has been involved in advanced control projects in over 16 countries, expert systems, model predictive control, and fuzzy logic. Mr. Ruel is an expert who has audited many sites and has led many successful projects with Rio Tinto, Glencore, Barrick, and others. He's a pioneer of fuzzy logic in Canada and has implemented it successfully. Mr. Ruel has long-standing relationship with his client and has published many papers presenting sustained results and performance years after their implementation. He is the author of many books and publications, as well as a software designer for instrumentation and process control. He has also taught at several colleges and universities. I will now hand you over to our presenter, Michel Ruel.
You see my screen?
Yes.
Okay, perfect. Thank you. So I decided to present today differently, just so we change. We do so many Zooms, Teams, and so on that I wanted to do this differently. So what I will do is I will present a project to my boss. I am waiting for this boss right now. I want to convince him to fund an optimization project. So the plant manager, Mark, is an outsider to our plant. He came here 3 years ago. He has a strong personality, a very high opinion of himself. He always claims that this plant has the best performance among our group. He absolutely hates PowerPoint presentation. He believes only in hard numbers. He prefers short meetings. Usually it's 15 minutes. So I convince his administrative assistant, Victor, with a sweet tart, cappuccino, and cheesecake to having with him 30 minutes today. So my boss is not an engineer. He is not a technician. He is more like a bean counter, but a very clever one. So with him, you have to go straight to the point. You have to be prepared. If you present a PowerPoint, it has to be very short. No technical words, no buzzwords, no acronyms. He especially hates control loop, PID control, advanced control. So with him, I stick to simple words like control system. Then, when you present a project to your boss, he must shine. He must see an advantage for himself. So just myself in this plant, in my role today, I am the process control engineer, I am the quality manager, I am the instrumentation team leader, I am the electrical engineer, and so on. Many hats, but process control is my baby. So the plant manager, like I said, has been here for 3 years. He had great successes. I will not say he is well liked, but he is respected. So he is a doer, he is a leader, he is an achiever. So that's the type of person we will be discussing, I will be discussing. Now, you will see on the slides what I have in mind, what I plan. My boss will not see this. My boss will hear what I am telling him. But you will see on the slides what I have in mind. Hello, boss. How are you today?
Hey, good afternoon, Michel.
Good. So, boss, I had an idea that I developed with Denise, our production manager, to optimize our production. That's why I'm here today to discuss.
Okay. So don't you think, Michel, we are already the best? You know, we already outperform other plants. We have excellent number. In fact, since I've been here a couple of years ago, we've reached new standard of excellence.
You know, boss, best is the enemy of good. When you think like that, you stop to improve. And since I am in process control, I always think about new ideas to do better. And I went to a seminar and they explained the benefits of optimization. There are many angles to look at this.
Okay, seminar, got you, Michel. I bet it's another trend like 4.0 AI, digital twin, and all that stuff. You know that I prefer real stuff. I like money, profits, reducing manpower. That's why I'm here.
Boss, you are a shrewd manager and you are a real leader, a doer. So your results are there to prove it. So can I present my idea? Can I have 15 minutes of your attention?
10 minutes, Michel. 10 minutes. And by the way, can you tell me how could you convince Victor to allow you 30 minutes? You're a really good salesman.
In fact, it's all about talking properly, explaining to Victor what I had in mind. And I had a good cappuccino, cheesecake, Remember cheesecake with Victor? He likes his cheesecake. And also, I told him that you will be so interested by my idea that you will postpone your other meetings. That's how I
Yeah,
convinced.
just go ahead, Michel. Clock is ticking. Clock is ticking.
So I had a discussion with Denise, and we discussed about which areas could be improved, which areas could contribute to increase our profits, what are the risks for our personnel, where could we reduce greenhouse gases, how can we reduce our raw material usage, how can we reduce our energy consumption, all that type of idea.
Yeah, Michel, that's all good question, but we've been there, done that already.
Yeah, but you promised me 10 minutes. So let me present my idea. So I had many other questions, but Denise told me, you know what? We discussed optimization and I thought about our grade changes. Since 2019, we are producing smaller batches. So we have to change in the furnace grade changes more often. And each of those grade change, during those grade change, we are losing production. The quality is off spec. So we have to reprocess that material. And every grade change, we have between 55 and 65 minutes of losses in production. If we can reduce this time, it will be pure profit because we will produce a little bit less manipulation, less reprocessing.
Well, that's easy to tell, but can you prove what you claim? Can you put numbers on your nice story? Can you come back to me with a precise project that I could present to our head office?
Boss, we have been working together for 3 years now. If I come to you, I already have the numbers. I already did the math. So if we can reduce the grade change from 50 minutes to 25 minutes, we will reduce the losses from 30,000 to 15,000.
Yeah, but why has not it been done before, Michel? Can you tell?
You know what? Few people, few manager, few process engineer understand process control. Remember, this is my bread and butter. This is my baby. I know simple tricks, very simple tricks. For example, if you know the dead time for a process, you can predict the settling time for this process.
Michel, I have no clue what is that time. My understanding is that right now it's that time for me. I have no clue about selling time, dead time, and all that stuff.
Let me explain something very simple. So I know that you like biking. So when you ride your bicycle, when you start to pedal, you have like 1 second, maybe 2 seconds before you initiate the movement. This is like inertia. This is what I call dead time. What I call settling time is the time to reach a steady state. For example, when you ride your bike, you start to pedal. After 1, 2 seconds, you start to bike. And after like 6, 7, 8, 9 seconds, everything is settled. So that's settling time. So that's how I based the basics of the estimate to improve the furnace. So the inertia, the dead time for the furnace is like 2.5 minutes. So if we can improve the tuning using properly the equipment already there and adding a little bit more information to the system, like feed forward or so on, we could improve the system.
Yeah, but just don't try to embarrass me with magic words and numbers.
Sorry, boss. So what type of car do you drive?
Well, you know, I have this nice Mercedes AMG.
Okay, so you have an intelligent cruise control on this Mercedes.
Yeah, sure, sure.
This intelligent cruise control, what they did, they use a cruise control system and they added more information to it, like LiDAR, cameras, and so on. That's exactly what we want to do with the furnace. The information is there, but not properly used. If we optimize the furnace, we will work with this.
Okay, okay, I understand. But please don't tell me that you will ask for new material or fancy programs that nobody will understand.
No, boss, nothing like that. So what I have in mind is very simple. We will measure actual performance. We already have the data. We don't have to add anything to this. We already have the data. We will do a project, which is process control optimization to optimize production. After that, we will measure new performance. We will compute generated profits, and then I will compute my bonus.
Your what? Bonus?
My bonus, let me explain. So if this project is successful, we will generate like 15,000 per week. You will shine, the production manager will shine, the head office will be very happy. Nobody will know about me and my team. So we will work behind the scene. So maybe forget the bonus, just an increase in my pay, and I will be happy.
Okay, okay, but are you crazy about that increase in your pay? Can you explain a bit more?
Yes, but it's already done. So what I need now is to make a presentation to you, a very simple PowerPoint to you.
Okay, okay. Well, Michel, you had my attention as I understand it now, you're trying to present a PowerPoint. You know that I don't like PowerPoint. I know that you may call it a presentation or anything, but I know it's a PowerPoint. It's a nice trick, but it's been there before.
Okay, so will you agree on a 10 slides PowerPoint, no visual effect, nothing fancy, as plain as a financial report?
Okay, okay, go for it.
Okay, so now I have the same presentation for Denise, Tim's, and the others. So, boss, don't be surprised. You will see a little bit of technical words, but I just wanted to use always the same presentation. If you don't understand some words, just don't look at it. So the numbers and estimates are very conservative. So I always start with the high-level view. The high-level view for this project is 3-4 weeks of work. Expected results is above 15,000 pure profit per week. The labor, 300 hours. The return on investment is less than a month. Let's stick to a month. The cost is under 50,000, and the results will be sustainable. One of the pain in the neck for process control optimization, is when the results are not sustainable. We have good results for 2-3 weeks, and then it goes away, it fades away. Not in this case. So this is the high-level view. Now, when we do an optimization project, we have 4 questions for operation, and we have 4 steps for our project. So the first question is, does it work? If something is not working, if a piece of equipment is not working, we have to understand why. The second question is, do you use it? And the equivalent for a project for this is to remediate when something is not working, not configured, not calibrate, we just make it work. And then we are sure that we can use it in the control system. Now, does it perform? That's really the key question. So coming back to my cruise control, it's very easy to have a cruise control going back to set point. It always go back to set point. But sometimes you need 2-3 seconds. Sometimes you need 20-30 seconds. In our case, the furnace is reaching the new steady state after 50, 60, 65 minutes. And we predict that if we optimize everything properly, we will be able to do it in 20, 25, 30 minutes. And the fourth question is, do you get the maximum from your system? And that's where we use more advanced control techniques. It could be advanced control. It could be PID plus something. It could be advanced regulatory control. It could be fuzzy logic. Usually, it's a nice way to better use the information. In our project here, it's very simple. So the project is, we have 76 pieces of equipment to look at: transmitter, valve, variable speed drive, and so on. And we will do this in the maintenance budget. We did not calculate an extra budget. Believe me, boss, I am also responsible for this budget. At the end of the year, I won't ask for an extra budget. We already have the budget to do it. Now we have 11 loops and control strategies. The preliminary work in our case is very small. In some project, we will need 2, 3, 4 weeks to prepare the project. In our case, we have been working on our documentation system, on our historian in the last year, especially because you asked always for good data. So our historian is in good shape. All the signals are scanned once per second, no compression. We have the real signal all the time. Our documentation system are updated. Our PNID are updated. Our standard operating procedures are in order. So we are, I would say, not lucky, but we're a little bit lucky because we did our homework in the last years. Now the assessment, 75 hours to review each piece of equipment, 140 hours to remediate, to repair, calibrate, configure, 33 hours only for optimization. And we can do this while the process is running. In fact, we will use the grade changes to do it. So no stop in production to do this project. Advanced control, we will add feed forward and constraint control. Performance evaluation, it's only 4 hours because we won't have to add extra measurement. All the data is there. We will compare before and after, hard numbers. Documentation, 24 hours. Total, 300 hours. So using $100 per hour, a mix of consultant and plant personnel, it's like 30,000. The team, 10 people, not full-time duration. Everything can be done in 3 weeks. So the material, we will replace 1 valve, 1 variable speed drive, repair few instruments, again from the maintenance budget. We have 1 consultant to coach us to ensure that we do the right steps at the right moment, 30 hours. I asked Denise to having with us Tim. Tim is our best trainer. Tim will be the salesman to the production people. He will work with the operator. He will work with the production engineer to ensure that they work with us, they understand what we do, and they will buy the project. So we need few maintenance people, a little bit of programming, others, total 300 hours. Now the preliminary work, that's why I said we are a little bit lucky because we are very well organized here. We did project in other part of the plant or in another plant where it was not the case. And it was really a pain to just collect all the documentation, all the data. In our case, we are very well organized. So we will prepare a database for the assessment, for the remediation, for the optimization. We will document everything. At the end, we will update the PNID, the management of change, and the SOP. Everything will be done properly. Then we will do the assessment. The assessment is visual inspection, configuration, analyze us using historical data in the PI system, analyze us using special software. For example, the flow meter, we have a program to analyze the performance of the flow meter. And we will make suggestions to improve maintenance. They will not really be part of the project, but just so the maintenance people see some benefits also in the project. Remediation, we will review calibration, we will configure equipment, repair a little bit of equipment. We replace 3 pieces of equipment, and we transfer to projects when we observe that if a pressure transmitter or a valve is at the end of its life, we will not change it for a project, but we will inform the maintenance for future. So now optimization, we will select properly the criteria to retune the loop to work on this. Now we are a little bit lucky again. So every time that we have a great change, we change the set point in the system. And a set point change is a disturbance to the process. And with that disturbance, we have a software to model the process and retune the loop. We won't have to bump test. We will just use the set point change. That will be enough. And since all the data is in the historian, we can even use the past and use a set point from 3 weeks ago to retune a loop, for example. We will review the control strategies. We won't develop soft sensors, but we need to optimize a little bit the 2 existing ones. And at the end, so we will consider APC to improve, stabilize, handle constraint, and so on. We decided in this project to not adding new advanced process control, but we will use advanced regulatory control, which is PID plus feed-forward, cascade, constraint control. In our case, feed-forward and constraint control. Now, the most important step that people will neglect, we will not neglect it, is to document properly everything, not only the documentation for the plant, but the performance measurement before and after. We will present results. I know we will be successful. We will spread the good news. We will congratulate the team. We will write in the newsletter for the plant. We will write about this project. And if it's well planned, the results should be better than expected. So, Bas, what do you think?
Well, that's good stuff, Michel. I really like that. You know what? I agree on the spot to let you execute the project, but you have only 3 weeks to do it, and then 3 weeks to evaluate the performance, and you start next week. So I'm out of here. Now, Michel, by the way, just remember that success has many fathers, but failure is an orphan. Good luck.
Thank you, Bas. We'll do it. So, as you see on my PowerPoint, I was not planning to do it that quickly, but we will do it. No. So, conclusions. So I will present 2 other examples, a real example that has been done in other plants, larger, bigger project, but you will see that's the same idea. So in this project here, it was like 7,000 hours, 13 people, 6 months. It was a whole plant that we read it like that. And you will have the PDF of this PowerPoint, so I don't go in detail on each. This next example here is 40,000 hours. It lasts, in fact, it was planned for 18 months. It lasts a little bit longer, but it's exactly the same step. It's exactly the same idea. You have to have a very methodical approach. So now, what is optimization? So it could be to improve productivity and efficiency. It could be higher yield. It could be to reduce unplanned shutdown. It could be to improve the stability of the operation. But if you do a project to improve the stability of the operation, it's not easy to having hard numbers on this. So the first project that you do in your plant or with your customer, ensure that you have a very simple project, easy to explain, easy to sell, but also easy to demonstrate the benefits. So it could be for the maintenance. Again, on the maintenance side, it's not so easy to demonstrate the value, like equipment lasting longer. to standardize management of control system, simplify the troubleshooting. It could be from the energy and environment side, lower energy cost, improve yield, reduce emission, reduce consumption of raw material, improve safety. Improve safety, it's very nice, but it's not easy to having numbers for this. Same thing for quality, better quality, improve quality control, standardized procedures. It's not so easy to explain, to present numbers from this. So now remember, before adding new equipment, new software, new control strategies, it's a lot easier to optimize. And a very simple definition of optimization, what it is to use properly what you have in your hands. So this is what is not so expensive. Make it work and perform. So step by step, 4 steps plus the preliminary. Do not underestimate documentation. Depending on the state in your plant, it could be really difficult. Just for example, to retrieve the calibration sheet. Communicate, explain. Don't be shy to present results. If you have a great success, don't be shy. Don't be humble. It's time to present good results. If you want to sell other optimization projects, what you have in your pocket is your best sales weapon. So the first project you do, be sure having solid and convincing numbers. That's it. Question now.
So thanks, Michel, for doing this wonderful presentation. There's you probably missed some of the comments, but people were honored to have you here and also saying they liked the format. So congrats.
Okay.
Hamza actually had a question about, is ARC the same as APC? Why use it, how to use it, and how to prepare technicians and engineers for a transition to it. And I see Mark is also typing an answer, but maybe between the two.
Okay, so APC is a very large umbrella. APC is Advanced Process Control. So Advanced Process Control could be MPC, Model Predictive Control, could be Fuzzy Logic Control, but it's also Advanced Regulatory Control, which is like PID plus feed-forward, or 3 PID working on the same variable speed drive under constraint control, and the more constraint loop is handling the variable speed drive, and so on. So now the DCSs, the PLCs that we have today, it's, I will not say easy, but it's doable to do that type of things. The old PLCs or the old DCSs, it was not so easy. Now, you need to having with you one experienced people to develop your control strategy. For example, when you have to select, is it better to use constraint control, cascade control, ratio control? We have basic principles to find this. And then I will say start with something very simple. Even a cascade control could be a mess if it's not done properly. Does it answer your question?
I'm not sure if it does, but perhaps there's more going on in the chat here. I see another related question. Oh, Hasma says, not really. Okay. What aspects would be best? Maybe Hasma or Hamza. Please elaborate.
So again, regarding advanced regulatory control, I don't see the chat. So
yeah, he was just referring to APC and perhaps. Okay. But we can always provide emails afterwards and connect the dots. So that's always an option.
Yeah, yes, but again, APC is so large that depending on the person of the book or the engineer, it can include almost everything. Usually we reserve APC for something which is a little bit more fancy than a simple PID. For example, model predictive control, where you work more like in feed forward than working in feedback. But in my case, I include in APC all type of, it could be neural networks, it could be fuzzy logic. In the case of advanced regulatory control, the main advantage is that you already have everything in your control system. You don't need to add or to buy new complex software. The problem with APC is when you add APC in a plant, usually nobody understands it, and very few people are working with it. Very few people understand it. It becomes a black box. And then the black box, only the supplier can work with it. That's one of the key point. Most APC project, after a year, you go in the plant and you see that the APC software is stopped because nobody understands it. And it should work.
And I suspect some of the other questions would be if people are seeing particular vendors or integrators in their plants, they might have some other questions. So in your professional experience, would you say that any one of the main DCS or PLC or industrial vendors would be easier than others for upgrades? Or is there a certain mark in the sand where you'd say a particular generation of products makes this more difficult than potentially like, for example, a Mark 5E from GE versus a Mark 6? Those kind of differentiations where the openness of data and those type of products really have enabled this type of optimization, or do people have to maybe particularly go backwards in time and have to do a forklift upgrade?
I can tell you, I start my career the same year as the PLC and DCSs appear on the market, 1975. You can go back to old Honeywell TDC 2000 or old Bailey system. They are 40-something years old. You can still work with them. What is the difference in the last 20 years or the last 10 years? That it's a lot easier to, for example, adding feed forward or constraint control in a very old DCS or PLC could be a pain. For example, Mark with me, we did project with very old DCSs, and finding the right trick to program a constraint loop was really something. With the new system, it's a lot easier. Now, I have to tell you that even in the new system, we still find bugs. Even in well-known systems, you have bugs. So if you are a good programmer, you will find a workaround. So you can do everything in an old PLC, but it will be more complex. Also, the old PLCs, the PID, the control was not really well done. It's better now. And in fact, today, the difference between a PLC and a DCS is purely academic. It's more like the same thing now. It's you program, you configure, but we still have bugs in those systems. That's why when you do optimization or you develop a new project, you have to test everything. And like I said, you will find bugs. You need to find a workaround for this. And if you have other person online like Mark, you want to add something, feel free.
Yeah, I've missed a part of this, Michel. I was answering some of the chats actually. So
I'll change it up a little bit. So Max had one question. So, and this is a fair one that lines up with the boss to aspiring worker conversation. So how does one convince a client to go into an optimization project when ROI has not been established yet?
That's really the first step. You need to find out. You need to calculate and find the ROI. This is really key. You need to do it. If you cannot calculate the return on investment, it's probably not a good project to sell to a customer. So that's part of it. As a consultant or as an engineer or a technician in a plant, you have to do this. And the idea of this talk today with my boss, Mark, was more for this. So engineers are very good engineers, very good technicians are not always very good to present a project. You know, I was going to the universities to talk with the students, and I always told them, when you will be working in a plant or in a company, your weakness will probably be your communication skills. It's not easy. The guy who will sell the project to his boss is not the best technical guy, is the guy who understands his boss and can put few numbers, convincing numbers for his boss. And that's what the idea for this talk today.
Great. And then Luis had another question here. He said, so in the same train of thought, what would be the step-to-step and to which parties would be involved to make those calculations? So he put in parentheses, results means dollars or savings, process time, operation time, other qualitative benefits. What would be that process that someone would come up with some figures?
You need to talk with the production manager, the production engineer. They have those numbers. Maybe they don't know they have the numbers, but they have them. So you need to talk with them. For example, in this case of furnace here, you talk with them and you say, where are we losing money? Where are we losing raw material? Is the performance adequate? Can we compare the energy per ton to produce this stuff compared with the other plants? If you have numbers, usually you will find an angle. And if you cannot find an angle to compute numbers, don't do the project, not the first one. You need to be able to sell and having numbers to tell your customer that it will be return on investment in X months, X weeks, and so on.
Great.
And one thing that's also sometimes overlooked is everything related to energy usage. So sometimes we focus like on throughput and quality and that kind of stuff, but energy usage can also be a good differentiator for a project.
Very, very good input on that one, especially if we're monitoring greenhouse gases.
I have an example. I have an example in mind. Years ago, we were working in Georgia. Maybe Mark will remember this project. And the plant manager told me, we have shit breaks in the paper machine. So, and we look at it, and I told him at the end, we need to look at where we prepare the pulp. So, and I said, I will send one of my guys, he will work 2 weeks on site, then wait and tell me in the 5-6 weeks after that if we improve or not the number of sheet breaks per day. So it's very simple. So one of our guys went there, he spent almost 2 weeks there just to retune, review the operation procedure and so on. And I still have the email somewhere, but the guy sent me an email and said, we went from, I don't remember exactly, it was 6 per day to 1.5 per day. And it said in 2 weeks, all the cost we invest to fix that problem, we had recuperate the investment. So guess what? He was asking me, where is the next place in my plant where we can do the same? He was convinced, and he was not convinced at the beginning. He was convinced when he saw the numbers. And that's why this presentation today is more, don't look at big projects. Look at small projects, then you can prove your point. After that, people will listen to you and work with you to find other places to recuperate money or raw material or stop reprocessing and so on.
Great. There was Tony had a couple questions here. So he said typically there's pushback in many plants as instrumentation upgrades become a large cost for projects beyond just the maintenance budget. So I'm assuming that would be like a capex. So he said, as you know, many, for example, control valves are size too big. Installation points contribute to dead time, etc. How would you tackle these type of barriers?
It's true. It's the same everywhere. The valves are too big, the valves are too old, the positioner is not performing, and so on and so on and so on. So if you can tackle one or two loops where it's so critical that replacing that valve will generate some dollars, then it pays for itself. But you have to prove it. If you go in a plant and you tell the guy you have to replace 355 valves, he will not do it. But if you tell him you have like, hello, Tony, I remember Tony now, Tony, you're a long time. So if you go in a plant and you tell the guy you have those three valves, there's three pinpoints in your plant, replace those three, we will work with you, we will improve your process, and here is the money coming back. You have to prove your point. And it doesn't worth it to replace all the equipment, but to replace all the equipment that can improve your process.
Perfect.
So if you sell valves, for example, you should be able to go in a plant and estimate roughly the price, the cost to replace the valves. This you know. Now the benefits replacing the valve, if you can estimate the number, then you can sell this to your customer.
Makes sense to me. Makes sense. Actually, I have a bit of a life story on that one, though, about the size of valves. Sometimes people, especially fresh graduates, like to make very optimistic estimates on the sizing of valves, and especially when you're in situations when they're not accounting all factors such as gravity. Such an engineering project did happen on the west coast of Canada, and because of that, even though the drawings were stamped and approved for purposes of optimization, 40,000 liters of diesel were dumped into a harbor. So sometimes the optimization can be the root of all evils. You just need to apply it in the right way, as you said, with the right returns on investment and proper considerations for HSE, health, safety, and environment. Paul Nelson had another question here. He said, any experience developing, I think, an expert system? Can you recount just a little on how you would develop the rules?
Yeah, I have many of those examples. I have one in mind. So we were working in Asia in a plant, and we discovered that the flow meter for the mineral were not working and could not work, and it will be millions to replace them. So it means that the control loops could not work properly, and we developed a soft sensor within a soft sensor, and we start to work on this. And many of us in the company went to this plant, and it has been very successful. We work with the operation. We develop a fuzzy logic system in this case, plus soft sensor, step by step with the process engineers. And it worked well, and it saved like millions. Now, one of the tricks is don't call this an expert system. Most managers hate this word. So call this a soft sensor, call this a intelligent control system, but expert, this buzzword is burnt. Don't use it anymore. But when you develop an expert system, most of the time, it means that you are developing an advanced control system very specific to a part of the process. It's different in the oil and gas industry, especially in the refineries. The advanced control system, the EPCs, has been developed like 50 years ago. They are mature, they are well known, they are used, and it works. If you go in the mining industry, or if you manipulate solid and rocks, not liquid, it's not so easy to measure. So the measurement is tough. The control is tough. And the valves or the pieces of equipment that manipulate the material, it's not so easy as well. So if you develop an APC in the mining industry, usually it's not a 50 by 40 variables. It's like 3 by 8. It's a smaller system, but a lot more complex.
Yeah, and maybe to add on Paul a question about really how to develop the rules, I can add a bit about this example, Michel, that Michel was talking about, because I actually been there in that project in Asia for weeks and weeks, and the rules they're developed two-way, and it's usually the case. So if you have like a very good operator that know his stuff and know exactly how to control the system and overcome the different issues that arise, you just sit down with the best operator, you take notes, you build rules out of that, and then obviously you can fine tune, but it's a very good starting point. And in that case, like for this project, it was a brand new plant, a brand new type of process. And you know how it is, every time people design a new plant, they want to make it bigger. So it's the biggest type of this in the world and blah, blah, blah. So obviously no one has any experience. It doesn't work as planned. So you do DOE, you do a kind of design of experiments. So you sit down with the process engineer, the experienced operator. Well, in that case, they had a few months of experience, and then you try, and you as you try, you discover really how you need to control this process to achieve the proper operation, and you build the rule out of that. But when you do design of experiment, obviously you just don't sit there and try stuff. It needs to be prepared and well structured, unless you will just kind of lose your time. But sometimes you need to go to that extent. But really sitting down with the people, try to understand how they operate the things. That's really usually the first thing to do. And we can do a lot by listening to experienced operator, honestly.
Great. I see there's one last question here from Hamza. If possible, Michel, could you share some real experiences of transition to APC in oil and gas? I suspect there's plenty on well pad optimization that you can probably share about, but if you have any examples, I'm sure they would love to hear some of them.
But yeah, I started to explain before. So like I say, APC in the oil and gas, especially in the refineries, it's very well known, and you already have packages. So if you have a catalytic cracker, the control system will probably come with the catalytic cracker that you buy. It will be part of it. And the valves are properly sized, and everything has been done. It's very well known for 50 years. So if you work in other areas, in the food and beverage industry, if you work in the mining industry, if you work in the metallurgy, it's new for them. It's new, 20 years, maybe 10 years. It's new for them to use advanced control, and the system are more customized for each case. In the oil and gas, it's already developed. So company developed 50 years ago model predictive control for a cat cracker, for this or that. It's well known. So if you work in the oil and gas, you will probably have the company who sold you the APC will send their engineer to work with you. But if you work in other industries, it's a little bit new, it's not well spread, and you need to know a little bit more what is under the hood. That's the big difference for me. And in the mining industry, you will find a lot of fuzzy logic. Companies like Metso and others have been using fuzzy logic for 20 years. You will never see, or very rarely, you will never see fuzzy logic in the oil and gas or in the petroleum industry, because they manipulate liquid. All the equations are well known, the chemistry is well known, the control systems are well known. You go in the handbook at page 245, and they will tell you with this type of tower, your control loop for temperature is on the plateau number 27, and the set point is 245, and so on. So it's very, very well known in the oil and gas industry. If you go in the mining industry, why are they using so much of fuzzy logic? Because the models are not well known, and the mineral that you are processing in your plant can vary by a factor of 5 to 10. So one morning you have soft rock, and the next day you have very hard rock, and the process is like totally different. So the mining industry is an extreme. The petroleum industry is the other extreme, chemical versus physical. And between those two, you have pulp and paper, food and beverage, and so on and so on.
And can you tell Michel a bit about what happened upstream, like in the oil and gas? If we talk like about offshore rig, FPSO, and
interesting. Yes, they are using very simple control system, but very complex measurement. They have a lot of soft sensor. They have like trying to predict exactly what will happen. If you look at the movie, the platform, the offshore platform, the Horizon offshore platform, if you look at this movie, you will see that it's very complex for measurement, but the controls themselves are not so complex. Other questions?
On that, just talk about food and beverage or anything like that, like even pulp and paper. Often the same lines and the same cells are making variations of product, right? So you're making paper, but you might be making a different grade on a per order basis. You might still have a pre-selection of grades that you will choose. How do you apply the models that you're suggesting in a multimodal approach where you can pick and choose between them? Would you have to reload your logic or reload set points, stuff like that? Because I'm sure everyone thinks one model to rule them all, but that's not reality.
Mm-hmm. So it really depends again of the type of industry, but when you, on a paper machine, for example, they use APC and they have banks of models because you will not produce on the same paper machine all type of papers. It's very like limited, but even there, they have a bank of models. In the pulp preparation, it's coming from the trees. So the more you are physical, the more complex it is. So when you prepare your pulp with different type of trees, with different recipes, you will have banks of models, and you will have like some predictive modeling trying to support the control system. It can become very complex, and a lot of people have developed soft sensor on the color, on the texture, on the consistency, to be able to predict how to improve the quality of the product. And the pulp and paper industry is interesting because I start my career in the pulp and paper industry. And 40 years ago, the sensors were not there. Even a good consistency measurement was not really good 40 years ago. But like starting like 20 years ago, 25 years ago, a lot of new sensors have been developed, and it really changed the way we do process control in pulp and paper industry because the sensors became available. The mining industry is at this stage. They have new sensors coming every year, and it's a little bit new. They were working mostly blind in the past.
Makes sense. Makes sense to me. I mean, I've seen some very interesting stuff with the production of cheese. Everyone thinks when a line is making mozzarella, it's all it will be doing, or it'll be the same grade of mozzarella, but that's not the case, and it's made at per time of purchase. Especially if you're in Quebec, you'll appreciate that Saputo is probably making the cheese and different variations of it for all of your pizzerias. So I can see how all that is very, very true, and it's actually more common than people can believe. Just that for various reasons, people haven't engaged in these type of projects unless they see dollars. I don't see any other questions here, but maybe there's some other ones. Maybe Jessica, Max, or Mark, did you see any others, or anyone want to add any last minute questions? Oh, I see one from Paul here. Michael, have you ever worked in a municipal water treatment plant? And if so, what aspects of the process were optimized? So happy that's
Yes.
not a security question.
Yeah, yes, in fact, I worked years ago a lot with the water processing plant for the pulp and paper industry. And then I work in the municipal water treatment, especially the one in Quebec. So treatment are not so complex, but you have quality to maintain. For example, pH, number of bacteria, and so on. And but you work with large, you process large amount of water, and usually you can recuperate if you have bad control in the lake before sending this to the river. So usually you have ways to recuperate if the treatment was not perfectly done, especially for pH, for example, which is a very complex process control loop, and usually it's not really well done. So you don't have a lot of process control, but you have a lot of laws and you have a lot of parameters to maintain within a certain band.
I would say, Michel, that probably especially for drinking water, the most critical one maybe is to control the chlorine, because it does, as the water is going into the system, it's not put in the reservoir. So if you put too much, you'll kill people because it can be toxic. If you don't have enough, you can have bacteria and stuff. But the thing for that is the company have built specific system to dose the gaseous or liquid chlorine for water, for drinking water application. So because of that very specialized type of equipment, it's fairly easy to do, but that's probably the most critical one. Because yeah, like you said, Michel, if you mess a little bit with like the pH, you are in a huge tank, so you can recover, and everything will be all mixed together. So yeah.
Do you have any? So Hamza has another question for you, and it's more of an informative one. Do you have recommendations on where someone should learn APC besides probably the books you've published in previous lives? What would the learning paths be? Webinars and blogs? I'm suspecting ISA is definitely the place for someone to go for these things, but perhaps you know other places.
Depending where you are in your career, like I work with ISA in two groups. One of our group is the ISA Mentor Program. So it's for young engineer and young technician. And when they have a question, they ask the question to senior people like me, and we answer them one by one. And sometimes we discuss over the phone and so on. So the ISA Mentor Program is a very nice place to look at. We have specialized group as well, but I would say the mentor program is probably the best one for that type of question, and when you search something very specific.
Great. If anyone else has any other questions, we can probably let everyone get back to their evenings, and we will send out a recording of this to all the participants should they wish. And if anyone wants to get in touch with any of the ISA committee members, such as Jessica, myself, Mark, James, Max, just let us know. And we'll be happy to help you connect the dots and answer any questions.